Welcome back everyone. In today's video I want to show you how to extract data from the internet and get that into R using the rvest package. You see, I recently built this elaborate table using the reactable package inside of R. And I do want to show you how to build this table, but first we need to get the data. And for that we need to get the data from two websites, namely Wikipedia and Statistik Portal. And with the rvest package all we have to do is to take the URL of those websites, pass that into rvest, and then we have the data into R, and then we have to apply a whole bunch of data cleaning. And in case you don't know me, my name is Albert Rapp. I am a mathematician and data scientist, and on this channel I help R users with typical data science tasks like extracting data from the internet. So let's dive in and check out how that works. Alright, let's talk about where we get our data from. First I have German Wikipedia open, and on this page, if we scroll down, we do see a table here. And I believe down here there will be more tables, but the table that I'm really interested in is this table here. We want to have the data from here, and then we want to enrich it with another table or with information from another table from the website called Statistik Portal. And if we scroll down here, we do see here that this second table has a whole lot of information on the GDP of different states and Germany as a whole. So this is the table that I want to use to enrich the information from the first table from Wikipedia. So with that in mind, we can head to RStudio. And in here, I've already set up a quarto file. And in there, I've already put in a code chunk that loads the tidyverse and the rvest package. This is a great package for web scraping in general. If you want to really grab a table like we want to do right now, then rvest is the way to go. Alright, so let's create a new variable. Let's call it URL wiki, where we just put in the URL of the Wikipedia page we've just seen. And then all we have to do is to take this URL and then we throw this into read HTML, which is from the rvest package. And if we execute this, we do see here that we get an HTML document with some weird HTML stuff in it. You don't need to understand all of this because the rvest package makes it really easy for you to avoid having to know a whole lot about HTML. Really, all we have to do is to pass this thing to the HTML table function, and this will extract all of the tables that we have found on this Wikipedia page. The first one, this one here, this is the one we're interested in because, well, this was the one I have shown you. But we can already see that it's a bit messy. If we look at this name here, there's a footnote 1. And in here, it looks really messy. And the reason why that happens is because if we look at the original Wikipedia page, then on there, we see that there is an A footnote. And well, the footnote is exactly what we can see inside of this stuff here. And this should already be a clear sign to you that we do have a little bit of cleaning work ahead of us. Another thing I want to draw your attention to is in the original table is that wait, let me make this larger for you. Now, if we look at this, for example, at this column here, this one says Fläche, which means area. So it shows you the area in square kilometers of a particular state. Right now, if you are not a German-speaking person, then you might think this says it's about 70 square kilometers. That cannot be right. And in fact, it's 70,000 because in German, we do use this point not for decimals, but for grouping numbers. So really, this isn't 70.542, it is 70,542. And this is something that can really mess up your code because then numbers will not be read correctly. And to avoid that, what we have to do in HTML table, we have to set the decimal argument. So if we throw this in there and replace this with a comma, then we can be sure that things are read correctly. Or at least in our case, things can be read correctly because in German, we do use a comma instead of a point for the decimals. All right, cool. So we do have this list of tables here. Let's just save this into a variable. Let's call it HTML tables. And now what we want from that is the first entry. So let's get that. And we do really have to do something about the column names. You see, if we throw this into col names, then we see that this is a mess. And even worse, if we look at, for example, this thing here, Hauptstadt, which means capital, if we copy and paste this part here and throw this into our console, then we do see here, there is a special character for some reason in there, and that's really annoying. It doesn't look like that in here, But if we look over here, we do see here there's this dot whatever thing, and this makes everything really weird. So if we want to rename and select columns from our table, from this one here, then we do have to use not these names here because they will not work. Instead, we can just use numbers. So let's just remove this part here and then use the select function to select the columns that we want. So let's grab this second column here and call it state. Let's take the fourth column and call it capital. And similarly, we can just take the most populous city from the fifth column. The number of votes that a state has in the Federal Assembly is the ninth column, and the area in square kilometers is the 10th column. The population in million is the 11th column, and the population per square kilometers is the 12th column. And now if we look at this, we have our data set now. I hope that you have noticed that I've translated the original column names to English so that it's a bit easier for you to follow along. So that's totally for your benefit. You're welcome. Anyway, let us throw this thing into a new variable. Let's call it selected state that. And now if I take a look at this data set, one thing that I might notice is that things that should be numbers, like the Federal Assembly votes, isn't really encoded as numbers. Same thing for the area in square kilometers, it is also encoded as a character. The reason for that is that in this case, for the Federal Assembly, in the last row, there seems to have been a footnote again, and this is why there is a B inside of that column, and this is why R treats this whole column as a character. And similarly, we have already talked about how German numbers are written differently than what you might know. So this is why we have to tell R that this is a German number, and it should make this into a machine readable English number. And the way to do that is to first create a new code chunk, and then we have to define a German local. So let's create a new variable that we call German local, and then we can use the local function. If you look at this data set, then you do see here that you can set up a whole lot of things like date names, date format, and so on. But what's really interesting for us right now is the decimal mark and the grouping mark of numbers. So here we set this to the German settings, namely decimals are encoded with a comma and groupings are encoded with a dot. And now we can use this local inside of a parse numbers function. So let's take our data set and throw this to mutate. So we can start off by overwriting the Federal Assembly votes using the parse numbers function where we stick in the original Federal Assembly votes column. And then we tell the parse number function what should be treated as a missing value, namely the thing that we have in our current data set in the current column and in the last entry, the 17th row. So let me make some more room here for you. And then we still have to tell parse number what the current local should be. So inside of the local argument, we set it to the German local we have just defined. And now if I execute this part here, let me minimize the documentation, we do see that the Federal Assembly votes now became a double vector. Now though, we do have a missing value in here now because we told parse number that it should treat the thing that is in the last row as a missing value, and that's what it did. But really I would like to have a number in there, namely the sum of all of the votes. So let's make that happen. Let's overwrite the Federal Assembly votes column again. And in there we can use the if else function to check whether what is inside of that column is a missing value. And if that is the case, it should just take the sum of the Federal Assembly votes. And if the number is not a missing value, then we do have to just leave the numbers as is. So let's just throw this in there. And now if we execute this, we do see that we still have a missing value in here, but that's because inside of the sum argument, we have to tell it that if there is a missing value, which there is right now, it should just ignore this. And now we see that in the last row, we have the sum of all of the votes. Now what's left to do is to take this area column and the population per square kilometer column and also turn that into numbers. If we look at this data set, we can do that in our table viewer. We do see here that the last row, it already has numbers for these things. So there we don't really have to do this extra trick of computing the last row. We just have to do this numbers parsing. And we don't even have to specify what the missing values are because those columns do not have any missing values. And since we have to do the exact same calculation in both cases, I will use the across function to apply the same thing on both columns. So I will tell across that it should iterate over these two columns, and then it should apply the function that just uses parse numbers, where it uses what the function argument is in the first argument of parse number, and in the local argument of parse number, it should once again use the German local that we've defined earlier. And now we do see here that the area in square kilometers is really turned into a double vector now, and we do see here now that the numbers look different. I mean, the numbers are the same, but if we look at the original data set, we can still see here that everything is encoded as a character, and we do see this point even here. But if we execute all of this, we do see here that this is a double now, and the numbers, they look different in the sense that there's no dot anymore, and it's nicely formatted so that it's easily legible that we have 35,000 here. So with that, we have formatted our numbers. Let's have a look at our original table again to see if maybe there's something that we might want to clean up here. And I noticed that, for example, in the Bremen column, there is this parentheses here, Bremen de facto. I don't really want to have that, so I will just throw this out in my data set because I know we don't see this right now because the columns are too small. But if I were to select only state and capital, I'd see that we have Bremen de facto in that table as well. And really, I don't need that. So this is why I will just remove this. So that's why I will target the capital column again and use an if-else function to check whether in the capital column I do see Bremen. And if I do want to make this into Bremen and not Bremen de facto. And in all the other cases, I will just leave the capital column as is. And now we do see that this looks a little bit nicer. Also, another thing that I want to check in my table is that the Wikipedia table matches the table that we want to extract from Statistik Portal in terms of names. So I do want to make sure that all the names of the states are spelled exactly the same so that we can join these two data sets later on when we'll extract the second table here. And one thing I do notice here is that this last row that's called Deutschland is in the other table called Bundesrepublik Deutschland, which is the more formal name, I guess. So this is why we have to adjust what we have extracted from this table so that the last row matches the name from Statistik Portal. So that's why we will do exactly the same trick as before, but now we will target the state column. And now if we see the name Deutschland, then we'll just make this into Deutschland and not Bundesrepublik Deutschland. And in all the other cases, the state should be left as is. Cool. So with that, we have cleaned up our data set here. Let's just remove the select part. And also let's save this into a new variable. Let's call it clean state data. And with that, we have everything we need from the Wikipedia table in one variable. Let's create a new code chunk and extract the data from the Statistik Portal table. In terms of scraping the data, it's the exact same thing as with the Wikipedia table. We just define the URL, then stick this into read HTML and pass the result of that to HTML table, where we specified that decimals are written with a comma. And once again, we see here that we get a list of tables, namely 3 things. And this time, the second table is the one we're interested in, because if you recall, the table that we wanted to look at is not the first one, but the second one. So this is why the table that we want shows up as the second table inside of R as well. So let's call this HTML tables again, and then let us grab the second entry once again, and then we do have a data set here now. But notice that the column names are really terrible. It always says Bruttoinlandsprodukt bereinigt verkettet something something. And the reason for that is that in our table, the first row is like a merged cell. But that's not particularly useful inside of my table. I don't want to have always the same column name. So this is why inside of the HTML tables function, I can set the header argument and I set it to false. And now I get a little bit of a nicer output in terms of the column names. They are generic, but at least I don't have like a whole list of what an actual column name is supposed to mean. So this is why these things are actually nicer right now, but don't worry, we will make all of this actually nice. You see, the thing that I really want here right now is to have this thing as column names. And for that, the janitor package has a really nice function that is called row to names. And in there, you just have to specify which row number should really have the column names. So in there, I will just set row number to 2 because that's where my names are. And that way I have removed everything on top of the second row. And this thing became my first row or my column names. And now we do see here that we have another extra row. So let's get rid of this. Let's throw this into slice. And we want everything but the first row. We got rid of that. And now I do want to start with the data from 2015 onwards, because here we do have like an irregular interval and I don't want that. That's why I just throw this out. So I will just pass this to select. And then I want to have everything but the second, third, and fourth column. And that way my data starts at 2015. But you may have noticed that there is actually no data for 2016. It goes from 2015 to 2017. And I really want to make it obvious that this is the case, whether you realize that there is something missing or not. I really want to make it clear there is something missing there. So that's why into mutate call, I do throw in a new column. I will call it 2016. It's a really bad name and we'll fix all of that. But for now, this name makes it really easy to fit into the pattern of the current column names. And in there, I will just throw in NA character and I will put this column before the third entry. And then we see that, okay, I have the 2016 data in there now and it's missing every time. So now what's left to do is to make all of these things into actual numbers. Well, not all things. This column here, the one that has the name of the states, this one can stay the same, but all the other things, they are encoded right now as characters again, because we have to tell R how to translate these things into actual numbers. And for that, we can use our friend parse numbers again, but we have to apply this to all of these columns here, which is a pain unless we use a cross again. So let's use a cross. And in the columns argument, I will specify that I want to target all but the land column. And the function that I want to apply is just parse number. And in there, I will just use x as my argument. And the local, this one should be the German local again. Now, if I execute this, I do see that all of these things became numbers now. So that's pretty sweet, but this isn't a nice format right now. I do want to have this in a tidy format so that I can summarize the data for each state. And this is why I passed this data set to pivot longer. And in there, I once again say that I want to target all the columns but the land column. These are the things that should be rearranged. And the names should go to a year column and the values should go to what we call GDP. And now everything is nicely rearranged. And technically this year column isn't encoded as a number, but this doesn't matter to us because we want to summarize only the GDPs anyway. So that's why we throw this to summarize. And in there, we specify that the GDP should just be a list of the current things that are in GDP. And I want to do this by land, by state. And now for each row in my initial data set, I do have a series of 8 numbers that correspond to the evolution of the GDP over time. And now the only thing that is missing is to rename my column, because I don't want to have this land thing here be, well, named like that. I do want to call it state. And clearly I forgot the order of things again. I don't use rename that often. So this is why I had it in the wrong order. So it comes with the new name first, should be equal to the old name. Anyway, this is our data set now, and we can save this into a new variable. Let's call it GDP series. So with that, we have 2 separate data sets that we have cleaned up for our purposes. Let's join them. So let's create a new code chunk, and then let's take our initial data set, the one from Wikipedia. Let's stick this in here, and then let's pass this to left join and combine this with the GDP series. And we tell it to join by the state column, and we have to use a character instead of just a variable name. And now everything works nicely. And in our initial data set, we have this list of GDPs now. And finally, because I do want to make this into a table later on with all the coat of arms, insignia, images, however you want to call it, because I want to have all of these things in my table later on, I need to throw into my data set the URL of where the images are located. So this is why I create a new vector, and in there there's nothing fancy but URLs that lead to the images that we have seen in the Wikipedia table. So now that we have this vector, we can just throw this into our new data set, and let's call it img. And in there we just throw in the vector, and we want to have this as the first column in our data set. And now we do see that it's in here. And with that, we have our data together and we can throw this into a new variable. Let's call it German stats. All right, nice. So we have done a whole lot of web scraping and a whole lot of cleaning. Let's do a little bit more of that because there's one more thing I do want to get from the internet. You see in my final table, I do want to have some additional information, some text about the states. But of course, I don't want to write this myself. I just want to extract that information from Wikipedia. For example, if in our table, we just go into Baden-Württemberg, we do see here that there is always some information about this state. And if we want to make this into English so that we know what this actually means, even if we don't speak German, then we can just take the URL from the English Wikipedia of Baden-Württemberg, and then we always want to extract the first paragraph from there. And I say always because clearly we don't want to do this only for Baden-Württemberg, but also for all the other states in Germany. So this is where we once again have to do a little bit of web scraping to extract not tables from Wikipedia, but actual paragraphs. So let's do that for Baden-Württemberg first. And once we have figured out how to do that, we can repeat that process for all the other states. See here, I will just copy this URL, and inside of my Quarto file, I will just throw this into a variable that I call URL, and then I will save this one in here. Now to scrape data from that URL, the idea at first is exactly the same. We have to just throw this into read HTML. And if we do that, we once again get an HTML document with a whole lot of stuff. And if we want to extract something specific from that, we have to pass this to an HTML elements function. And in there, we have to somehow describe the things we want to extract from this whole document. And the thing about HTML is that there is an HTML tag for everything. You can have bold text wrapped into strong tags, or you can have headlines that are wrapped in H tags, or you could have paragraphs that are wrapped in P tags. So if we want to grab all the paragraphs from that page, we just say, okay, look for the P elements. And if we do, we get a whole bunch of paragraphs here. And if we look at that, we still see that this is an HTML thing, but we do only want to get the text. So let's throw this to HTML text. And that way we do get a vector full of text. And if we scroll all the way up, we do that, a little bit of scrolling, then we do see here that the thing that we really want isn't in the first entry, but in the second one. So let's just save this into paragraphs. And from there, let's extract this second entry. And now if we look at this, it doesn't look perfect yet. I mean, we can read the text, it says Baden-Württemberg, and then there is some notation on how to pronounce this. And then there's weird stuff. And then the text continues with Baden-Württemberg, commonly shortened to BW or Bavü is a German state, in parentheses land, and so on. So we do get the thing from Wikipedia, but there's mess in there. And if we look at the original, then we do see that, okay, the stuff that we extracted is really in there. There is this notation of how to pronounce this, but then there's a footnote again, and this is the exact mess that we've had before. We, for some reason, extract those things, and then they are in our text. So this is why there is some mess here that looks like this. So really our job now is to clean all of that up with a little bit of text processing. And to do so, one thing that we notice is that this footnote, after it comes, this bracket 6, there is this .mw-parser output something something, and then all the way to some curly brackets, and then there's another .md parser output, whatever, all the way to another set of brackets. So once we have noticed this part, we could use regular expressions to remove that part. Let's try that. Let's pass our result to str remove all to remove strings from our text. And the first thing we should try is to just get rid of this MW parser output thing. So let's just copy this part in here. But one thing that we have to watch out for is that we are currently looking for a literal dot. In regular expression, the powerful language that can really help you with text cleaning, in that language, the dot means any character. But we don't want to have any character. We just want to have a literal dot. So we have to tell R, use a literal dot. So that's why we throw in these backslashes in here, because that's the signal for R and regular expression to ignore this. And now if we execute this, we see that we got rid of this .mw parser output thing. You see, after the bracket 6, it starts with the other stuff, and now it's still, all the things are still remaining, but we are one step closer to remove things. You see, another thing that we could try out is to remove things between the curly brackets. So let's just throw this in there. And then the first thing we have to notice that these curly brackets are another set of special characters in regular expressions. So we have to do the same thing of telling R and the regular expressions that we are looking for literal brackets. So now if we execute this, we see that we got rid of this font size 85% thing here, but the font size 100%, this part is still in there, because clearly we cannot remove this if we say look only for font size 85%. So this is why we use a little bit of tricks from regular expressions to tell it, you know what, just look for anything that is between these curly brackets. We are just kind of assuming right now that real text, the thing that we're looking for, will never use curly brackets. So if you find curly brackets, delete them and everything that is between the opening and the closing bracket. So this is why we don't put in font size in there, but we use this special character that says regular expression will look for any characters using this dot. But clearly we are not looking for one single character. We are looking for a whole set of characters like font minus size colon 100%. This is more than one character. I could count this, but it's literally more than one. Let's just go with that. So this is why we have to tell R and the regular expression, hey guy, I know you can remove any character, but do me a favor, do a little bit more than just one. Do as many as you can find between curly brackets. So this is why we instructed to do that using the plus notation. And now we got rid of all curly brackets and the content between them. So that's pretty cool. But in this example, we have never removed this .mw parser output thingy, but now we can combine our first and second example. So let's take our first example, and then let's say we also want to remove this part here. So let's just throw this in there as well. But now we are missing the things that are between this start of mdw parser and the curly brackets that are the end of the things we try to remove. So what we can do right now is to do the exact same trick of saying regular expression, please be nice, look for something that starts with this weird thing and ends in these curly brackets that have something inside of them, and remove everything between them and also the start and end thing. And now if we execute this, we got rid of this whole thing. Nice. I hope you're pretty proud of what we've accomplished. That is no small feature. We got rid of a lot of annoying text. I wanted to say all, but there's still something in there, but we have figured out the hard part. Now we can just throw the result of this to more string R functions to remove even more things. Let's start out by removing these brackets here. We do have brackets and then numbers inside of them. We don't want to have that in our text. So let's just remove all brackets that have numbers between them. For that, we want to use brackets, but once again, these kind of brackets are special characters in regular expressions. So once again, we escape them using double backslashes. And now we want to look for numbers between the brackets. We could use a special character. This would get the trick done, but that might be dangerous because this dot special operator will not only match numbers, it will match anything. So that's why instead of using this dot, we use the special notation for numbers, which is \\d. And with that, we get the exact same result, but we're a bit safer. But if you look at our text now, you do see here that there is still a bracket with update in there, which is probably another special notation from Wikipedia, which we don't want. So let's throw that out as well. We could do this part here once again and just replace this thing here with update, and it would get the job done. Here we would just look for literally the word update between brackets, but that's a little bit of extra code that I don't want. So let's try to make things concise. Let's just tell this regular expression, the first one, to look for brackets that have either a number or the word update between them. So this is why we put this into parentheses, and then use a vertical line to say either or, and in this case we say either a number or the word update. And there's these parentheses to keep these things together as a group so that the regular expression knows we are looking really for a number thingy or for this update text. And now we get the exact same result as before, but the code is a little bit conciser. Now, one thing that I'm missing in my regular expression right now is the fact that, I don't know, maybe footnotes can go all the way up to 100 or whatever. Right now, we're looking only for one single number. And to avoid that, let's just tell the regular expression that it can look for multiple numbers. Once again, the output stays the same because we only had footnotes 1, 2, and 3 and so on. But still, I don't know what is in the other links when we do the same thing for other states. So let's just throw this in there. And similarly, we have also seen Wikipedia denote footnotes or something else with just one single character. So that's why we, after all, we throw in this dot, but we try to make sure to look only for one single dot and not multiple ones. So with that, we have a nice regular expression to remove a whole lot of footnotes and special annotation from Wikipedia for us. Now it's time to throw out some special characters that are just annoying, like this \n or this icon here. So that's why we just throw in another set of string remove all functions, and that way we got rid of those. And then finally, I do want to replace this km2 to actual square kilometers. So that's why I throw this string replace all in there, where I replace this km2 with actual square kilometers. And now if I execute this, I do see here that this looks nicer. Nice. So that is my output. This is how I have cleaned the paragraph text from the first paragraph of the first state that we want to look at. Time to wrap this thing into a logic. So that's why we take the stuff here and we write a function. Let's call it get state description. And as an argument, it will just take the URL and then it will do the calculation that we have just done. But of course, we don't need to have these intermediate steps that were there for us to figure out how to set up this regular expression here. So now we do have a nice function and we can use it to iterate over all of the URLs to the corresponding Wikipedia entries. So for that, I throw in a vector, let's call it state URLs, and then I can use this vector and always apply one of those URLs inside of the get state description function. And now if I execute this, it will take a couple of seconds for all of the data to be scraped and cleaned, but the results look mostly good. But there's one thing that seems to be off. Here there isn't like something that starts with Hesse is something something, but it seems like it actually got another paragraph after the one that we're looking for. But in all the other cases, this looks like exactly like we want. So we have to modify our function a little bit to use the first paragraph in the case of Hessen and the second paragraph in all the other cases. So let's just create a new variable. Let's call it paragraph number. And now we can define that and say that, okay, if in the URL there is this word Hesse, then in that case, it should use the first number. In the other case, it should use the second number, or not first and second number, but the first and second paragraph. So now if we re-execute this, this should work out nicely. So the other states still look great. And now if we look at Hessen, there it is. There is the actual paragraph that we wanted. Nice. So with that, we have all of our text in here, and we can save this into a new variable. Let's call it state descriptions. And with that, we have got all of the data that we want. We don't really need to merge this new vector into a new data set. I will get this into the interactive table using some tricks from Reactable later on. For now, that's all we need. We do have our data set German stats, and we have an additional vector containing the state descriptions in here. And with that, we've also learned a whole bunch about web scraping and data cleaning. And if you enjoyed this video, then I'm very certain that you're also going to enjoy my data cleaning masterclass, where I show you a whole lot of more tricks to clean data into a usable format. This course covers a whole lot of tricks like the across thing or the parsing thing, or the regular expressions that we have talked about in this video, but it also covers a whole lot more, and you can find all of the information on that course by following this link here. And in case you're interested in learning about a very nice package for data cleaning, you can check out this video where I show you how the janitor package works and helps you to get the job done faster. And finally, thank you for watching, and I will see you next time.